Today we're starting a unit on right triangles, and the first topic is something that you already know a lot about, and that's the Pythagorean theorem. So let's get our foldable set up so that we're ready to take notes. It's going to end up looking like a brochure that you would pick up somewhere. It's going to be a trifold. So the blank space is going to be the back of your foldable, and you're going to fold in the left and the right flaps so that the Pythagorean theorem title is showing when you close up your little brochure. So I'll give you a second to do that, and once you've got that folded, I'd like you to copy the learning target for today on the back blank space that we talked about. The learning target is we will solve problems involving right triangles using properties. Let's go ahead and pause the video, make sure you've got it folded right, and this learning target is copied. So now we're going to start on the front of your foldable, and that's where the Pythagorean theorem title is. And I'd like to add to that title that it's for right triangles specifically. And there are a couple ways that you can write the formula for Pythagorean theorem. A lot of people use a squared plus b squared equals c squared, and that's perfectly fine. But I actually like to use x squared plus y squared equals z squared, because that x and y are going to represent horizontal and vertical lengths. And to me, when you're looking at a triangle on a graph or just a regular figure, knowing which side is vertical and horizontal is really helpful. So let's label this right triangle right under our title. We've got across from the right angle is the longest side. It's called the hypotenuse. The two shorter sides are called the legs. So we'll label the leg and the leg. And I mentioned the right angle, and we know that's there because of the box in the lower left-hand corner. Jumping down to the little example below the right triangle, we see something that we've used this year, and that is using units of length to find the distance or length of the hypotenuse of a right triangle. So what we have on the bottom of the triangle is the horizontal length, so I'll label that x. On the left side is the vertical length, and that'll be y. And then the long side will be the hypotenuse z, which didn't come out too great on the board. Hopefully your paper looks a little better. So let's just go ahead, just for practice, to get ourselves warmed up, write down our Pythagorean theorem and plug in those lengths. And they're really easy to find just by counting the number of boxes. So on the x side, we have 4 boxes. We'll need to square that. And on the y side, we have 3. And the reason that we can't just count the boxes on a normal graph, on a diagonal, is because they're not perfectly lined up. They are here, and so we'll get the answer that we see, which is 5. But normally on a regular x and y graph, we can't count them as easily as that. So 4 squared is 16, plus 3 squared is 9. We're going to add that 16 and 9 together. I think I had an extra square in there I don't need. Take that away. So we're going to get 25 equals z squared. And to solve for z, our last step will be to square root both sides. So we get 5 equals z. And that checks out with how many boxes are on the side of z. Let's jump over to the other flap, which has our vocabulary, and I just wrote down a few facts for each of these vocabulary terms. You're already quite comfortable with what these are. Let's go ahead and make a list of what we know. A right angle is 90 degrees. The symbol that we use for the right angle, some people call it a box, some people call it a square. In that angle, it's going to be that box symbol that we see. And lastly, a right angle is formed by perpendicular lines. I think I might abbreviate that. And even better, we could use the symbol for perpendicular, which is, of course, the upside down capital T. And it is exactly 2 perpendicular lines. That's a perfect symbol to use for that. Let's move to our next term, which is the leg. There are 2, which we saw in our first figure. They are the shorter sides of the right triangle. And lastly, we'll be using x and y to represent the legs in the Pythagorean theorem. All right, moving down to hypotenuse, it is the longest side. And you locate it not only because it's the longest side, but you can always look across the triangle from the right angle. And just to reference the Pythagorean theorem again, we're going to use variable z to represent the hypotenuse. So it's z in the Pythagorean theorem. All right, the last thing that we're going to be using today is the square root. And I'm sure you know what the symbol looks like, but let's put that down just for reference. And the only other thing I said about the square root is that we use it to unsquare a number. So if we have a variable squared that we'd like to solve for, we can use the square root to unsquare that variable and the number it's equal to. All right, so now that we've got all our definitions set up, let's go ahead and try some examples. I'm going to draw lines where you have the folds in your foldable, and we're going to do each section as we go from left to right. So for the first section, we're going to see if it's a right triangle or not. They give us the three sides of the triangle, and we're trying to determine if it's a right triangle or not. So what you want to identify first is your longest side. So I like to circle that, make sure I label it Z. Now the other two sides, the legs, are interchangeable, so it doesn't really matter which one's X or Y, but since this one's clearly horizontal, I'm going to use the 12 for X and the Y for 5 since it's vertical. So if you'd like to, you can write your formula out. If you feel more comfortable, you can go ahead and plug in the numbers as you write it out. So that would be 12 squared plus 5 squared equals 13 squared. And you're welcome to do that arithmetic in your calculator. 13 squared is 169, and then you would square the 12 and the 5 and add that together. And you get 169 as well. So if it checks out that the left and the right side are equal, we're going to say yes, that is a right triangle. So I think in the next example we might see the other situation when it doesn't work out. Notice we don't have a figure for example 2, so we have to be a little more careful about selecting our hypotenuse. We do know that it's the longest side, so again I'm going to circle it and label it Z. And since the legs are interchangeable, I'll just make the 9x and the 6y. So I'm going to go ahead and plug my numbers in right away since we've been using the formula a couple times already. So I get 9 squared plus 6 squared equals 10 squared. I know that 10 squared is 100. I've got to calculate the other side, 9 squared plus 6 squared. I ended up getting 117. So that is not equal to 100, obviously. So this would not be a right triangle. Okay, and these next two examples in that middle section, they're asking us to find the hypotenuse. And that's going to be Z for each of these questions. So you might want to replace that question mark with a Z. It's totally up to you. The horizontal side is 15, the vertical side is 8. So we've got 15 squared plus 8 squared equals Z squared. 15 squared plus 8 squared, I got 289, and that is still equal to Z squared, so we've got to do one more step to get it equal to Z, and that is to square root, so I can unsquare that Z squared, and that comes out to a perfect square of 17. Right under that, for example 4, I have X and Y again, I'm looking for Z, so 40 squared plus 30 squared. If you square the 40 and 30 and add that together, you get 2,500. You would square root both sides, and then you come up with Z equals 50. In our last section, we're going to be solving for one of the legs, so it's going to be X or Y. So I identify Z in the first example, it's 15. My vertical distance is Y, so that's 9. It looks like what I'm missing is my X value. So I'm going to write X squared plus my Y squared is 9 squared equals 15 squared. So I've got X squared plus 81 equals 225. I need to subtract that 81 from both sides. So that's going to give me 144. And last step to solve for x will be the square root. X equals 12. In our last example, I have my hypotenuse, which is 25. I have my horizontal distance, 24, which is x. And what's missing is the y. So let's start with 24 squared plus y squared equals 25 squared. That's my c. My 24 squared is 576. And the 225 is 625. So I need to subtract that 576 from both sides. And when I do that, I'm left with 49, which of course has a perfect square of 7. Great, so now that you've had a good review of Pythagorean theorem, you have some classwork to try with a partner, and I'll check you when you're done.